Hi, everyone. Welcome back to Algebra 1 with Miss Andrea. Today, we're going to continue with comparing and contrasting functions. And let's get this screen shared for you. All right, here we go. This is in the online book. If you're following along with PBA, it is going to be Module 7, which is titled Unit 5, Comparing and Contrasting Functions. And this is where the material we're going to cover in this lesson is featured on page 2 in that module. All right, so the first thing we need to remember, now this should be reviewed for you, is exactly what a function is. Now, a function is just a relationship, but it's a special kind of relationship, and it's a relationship, generally speaking in math terms, between numbers. So for every one input, you can get exactly only one output. And so that is the special relationship. So if instead of math, we were talking vending machines, well, your traditional vending machine, you may have multiple items that are 50 cents. So if you put in 50 cents, you can get any number of things out. That's a relationship, but it's not a function in relation to the amount of money put in and what you get out. Whereas if you had a vending machine where everything was a different price, or even going back to that first vending machine, what you plug in, say you want K1, okay, a Twix bar comes out. If you put in K2, a Snickers comes out. If you put in K3, trail mix comes out. That would be a function because for every one input, there's exactly only one output. So with the same vending machine, you can have different types of relationships. One can be a function when you type in the specific slot that it's in, or it could just be a regular relationship and a non-function if you're talking about the relationship between the money put in and what you get out. All right. So when it relates to math, we're talking about numbers, obviously. And we can represent these with ordered pairs. And remember, with an ordered pair, X is your input and Y is going to be your output. So for every input there's exactly one and only one output. So if you notice, when you're looking at a list of numbers, you don't see any repeats in the list of the X's. Okay, there's no repeats here in this function. If we talk about a standard relationship that's not a function, if we look at this, we can already identify that there's a repeat here. 3 and 3. I can put in 3 and either get out a 2 or a 5. That's why this is not a function, because if I put in 3, I should only have one thing, not a choice. If I put in 3, I get whatever is determined to come out of that relationship. So I've got some examples here for us, 6 examples to be specific. I want you to go through, pause the video, say whether or not, identify whether or not these are functions or not functions, okay? All right, let's go. Welcome back. So let's look at just the X values first, okay? -7, 8, 9, -7. Oh, there's 2 -7s. So this is not a function. 2, 5, 5. Oops, there's 2 5s. Already I can tell. I don't even need to look at whatever that is. It's not a function. 3, 5, 7, 9. Okay, I've looked at all the X's in this set. So now I need to just look at all the Y's. There's not duplicate X's. Oh, well, what I should have done up here in 1 and 2 is then looked at the Y's. If they both said 8, then that could have been a function, but it says 8 and 10. So those are 2 different numbers. That's why it's not a function. Here with the 5s, 1 and 6, it could have been a function. This, since I have no repeats, is definitely a function. Let's try that again. 9, -8, 3, and 10. There are no repeats, so that is definitely a function. 2, 3, 5, and -2. No repeats, definitely a function. 3 and 3. Uh-oh, already got a repeat. 3 and 3. Even more repeats. Okay, well, since we have some repeats, if all their Y's are the same, then there's still only one output for every input. So let's look at the Y's now. If I input 3, my output is 5. All right. If I input 3, my output is 5. Oh no, that's a 2. That's a different output for the same input. So that is not a function. All right, so now that you have some functions, you need to know how to solve the functions, right? Evaluate the functions. How do we do that? And this, again, should be reviewed for you. What that means is if you're finding f of x is negative 2x plus 5, find f of 7. That means wherever there's an x, you're going to plug in a 7. So right here, where it's x, you're going to plug in a 7 there. Stick it into your calculator. Negative 2 times 7 plus 5 is negative 9. So f of 7 is 9. That's your final answer. All right, so h of x is that. Find h of 2. So what I'm going to do is type into my calculator that. And I get 13. So h of 2 is 13 is my final answer. Now I'm going to look up g of x. So I've got a 3 there. If you notice, this is an exponential function because the x is the exponent. All right, so I'm going to put 2 caret 3 plus 3. And I get 11. So g of 3 is 11. All right, now here I'm going to plug in an 11 here. So negative 11 plus 7 is negative 4. There you go. That's how you evaluate functions when given the x. So now that we reviewed all of that, we get to take it to the next level. So we're going to take two different functions and add them together, or subtract them, or multiply them, or even you can divide them. There's so many things that you can do with functions. You can do a function of a function. Oh, they're so much fun. So here's what we're going to do. We have two functions up here. F of x is 3x plus 2, and g of x is x squared plus 3x minus 7. So we're going to have addition, subtraction, multiplication. Now, just because math is so fun, we're going to make it so that you can write each of these things two different ways. There's two ways to write addition: f of x plus g of x, or f plus g of x. They mean the exact same thing. So you got to have this written down in your notes, this chart that we're doing. You got to make sure you know what's what, right? So subtraction is f of x minus g of x, or f minus g of x. Either one means the exact same thing. And same with the multiplication: f of x times g of x, f times g of x. All right, so let's look at how to do this addition, subtraction, and multiplication. So f of x, I like it the other way. Usually how you're going to see it as you continue on in your math career is going to be written in this way. So that's how I'm going to do it. So you write out what you're doing instead of a y. You're writing that you're doing f plus g of x. And then what you do is you're going to write your f of x, 3x plus 2, and then you're going to add your g of x. And since you're adding, you don't need any parentheses. There you go. One more step, we just have to combine our like terms. F plus g of x is x squared is going to go first, and there's only one of those. I'm going to cross it out when I'm done with it so I can remember. I've got a positive 3x and a positive 3x, so it's going to create a positive 6x. Cross those out when I'm done. And I've got two constants, a positive 7 and a positive 2. It's going to create a positive 9. And that's everything. So you can see there my finished addition problem. It seemed a lot scarier than it was, didn't it? All these F's, G's, and X's. That makes it look scary, but it really wasn't hard. All right, let me change colors here. Let's go to orange. F of X minus G of X. Now this one's going to be a little bit harder. Well, not harder, but just you have to use some parentheses, right? And that's because we have our subtraction problem. So F is going to definitely go first. With addition, remember, it doesn't matter which one goes first, but F is definitely going to go first. 3x plus 2. Then you're going to put your minus, and this is where you need that parentheses. You're going to have to put your G of X inside of parentheses. Okay, x squared plus 3x minus 7. So what do these parentheses tell us? Okay, well, these parentheses are telling us that we're going to have to multiply this -1, because remember, there's an understood -1 there. We're going to multiply that by every term inside of these parentheses. So how does that affect it? A -1, I know when I multiply 1, then I get the same answer. So how does that affect it? Well, because of the negative, it means that we're going to change the sign in front of each one of these things in the parentheses. So F minus G of X is 3x plus 2, and then positive x squared will become negative x squared. Positive 3x will become negative 3x, and negative 7 will become positive 7. There you go. Now we need to combine like terms. All right, starting with the largest or the highest power is going to be negative x squared. Negative x squared. Then I've got my raised to the first power, a positive 3x and a negative 3x. Well, those are going to cancel each other out. And then I've got a positive 2 and a positive 7, so it's plus 9. And that is my final answer. Now, multiplication. This one, we have to put both things in parentheses. So I'm going to put 3x plus 2 in parentheses, and then I'm going to put x squared plus 3x minus 7. And you're like, Miss Andrea, that's too many terms. I can't FOIL that. I can only FOIL if there's 2 terms times 2 terms. Well, this is why I don't use FOIL when I'm multiplying, because you can use the method I prefer, my preferred method for any type of multiplication of not equations. What are these? I don't know. The term escapes me. The name for when you don't have any equal sign. An expression. An expression with any number of terms can be multiplied by any other expression using the traditional method before FOIL came out. So you're going to write the first term of the first equation, and then beneath that you're going to write the second term of the first equation. And if there are any other terms, you keep writing them on the way down, right? Make sure to keep your signs. 3x was positive, 2 was positive, so I'm good. Then you're going to multiply it. I'm going to need some more room. Let me do this. 3x and 2. I'm going to have to write a little bit smaller. All right. So I'm going to then multiply it by the second expression, x squared plus 3x minus 7, x squared plus 3x minus 7. Okay, now that I've got that done, I'm going to just start multiplying. 3x times x squared is going to be 3x to the third. 3x times 3x is going to be a positive, oops, I thought I'd switched back to green, a positive 9x squared. 3x times, oh, that's horrible, right there, negative 7. 3 times 7, 3 times negative 7, negative 21, so negative 21x. So I multiplied that by all 3 terms. I made sure to pay attention to the signs, so I'm done. All right, so now I'm going to look at this bottom one. 2 times x squared is going to be 2x squared. And I'm going to place it underneath the other x squared 1 there. Okay, then 2 times 3x. 2 times 3 is 6 with an x, so 6x, and they were both positive, so my answer is going to be positive. Then 2 times negative 7. 2 times 7 is 14. There's one negative, so it's going to be negative 14. Then we add these equations. There's nothing to add to that one, so it just carries straight down, 3x cubed, and then positive 9x and positive 2x is going to be positive 11x squared. I forgot to say squared for those, but it was there. Then you have a negative 2 and positive 6. It's going to end up being a positive 4. Ooh, that's not a negative 2. Let's go ahead and erase that. That's a negative 21 and a positive 6. Negative 21 plus 6 is negative 21 plus 6. Negative 15. Negative 15x, and then minus 14 because you're not adding anything to it. So this is our final equation. So f times g of x is 3x cubed plus 11x squared minus 15x minus 14. So as you can see, that one's going to be the most complex for you to get done. Now, it is not hard for you to do it. Long or complex does not equal hard, but it does mean that you have more opportunities for mistakes. So you do need to be extra vigilant, pay extra special attention to those small little errors. Okay, make sure you use your calculator when you need to for anything, bigger than 5 times 5, or anything bigger than 2 times 2. And make sure you use your calculator anytime you have any negatives. And just really pay attention to the details when you do this one, because that's where the errors happen. You need to make sure you pay attention to details here. All right, so now I have some practice for you. So I want you to practice these on your own. Pause the video. Here's the 2 given equations that you have, and I want you to complete all of these functions. You should have taken good notes on the last screen. If not, rewind, go take your notes, and then come back and try these on your own. All right, welcome back. So we've got g of x minus f of x. So g of x minus f of x. I'm going to start with g of x here. I'm going to write 2x squared minus 3x plus 1 minus f of x, 5x plus 1. Okay, now if I distribute that negative, what's going to happen? Well, my 5 of x is going to become negative. My 5x is going to become negative, excuse me, and my 1 will become negative. So I'm just going to rewrite this, because I don't really seem to have too much room. It was negative 5x and negative 1 that it became, right? Now I'm going to say, okay, we'll say that equals, this is going to be first 2x squared. Let's combine our like terms, our x's, negative 3x, negative 5x, 5, 6, 7, 8 is going to be negative 8x, because if you have the same sign, you combine. And then we've got a plus 1 and a negative 1, and those are going to cancel out. So g minus f of x is 2x squared minus 8x. And there you go. All right, now f plus g of 2. Let's see, we're going to do f first. So we've got 5x plus 1 plus 2x squared minus 3x plus 1. And all we have to do is combine our like terms. So we've got a squared here, 2x squared, and then we've got some x's. So 5x and 3x, 5, 6, 3 is negative. So it's going to be a positive 2x, and then a positive 1 and a positive 1 make a positive 2. So we're going to have f plus g of x is 2x squared plus 2x plus 2. And that is your answer to that equation. All right, f of 3 minus g of negative 1. Ooh, we didn't go over these. Let's see if you can, I hope you figured it out on your own. Instead of having x in there, what do we have to do when we see a 3? Well, we have to plug it in, right? So let's find f of 3. What is f of 3? F of 3 is 5 times 3 plus 1. Okay, that's 15 plus 1, so it's 16. Okay, well, let's find out what g of negative 1 is. G of negative 1 is 2 times negative 1 squared plus 3 times negative 1 plus 1. Remember, when you're squaring negatives, make sure you use your parentheses, or else you will get the wrong answer if you do not. All right, and I got 0. 2 times negative 1 squared plus 3 times negative 1 plus 1. Let's just do it without a calculator to make sure. Negative 1 squared is 1, times 2 is 2, negative 1 times 3 is negative 3, negative 3, and positive 2 is negative 1 plus 1 is going to equal 0. All right, so I did this and I did this, but what about the subtraction that's right there in the middle? Well, what you're going to do with that is now we're just going to take and do our f of 3. What did we get for f of 3? We got 16. So we're going to do 16 minus what we got for g of negative 1. What did we get for g of negative 1? 0. 16 minus 0 equals 16. So f of 3 minus g of negative 1 is 16. And that is your final answer. All right, moving on. F times g of x is, all right, so f is 5x plus 1, and g is 2x squared minus 3x plus 1. So we're going to multiply these. I don't see very much room. I'm going to do it up here. 5x and 1, they're both positive, so I'm good. And then I've got 2x squared minus 3x plus 1. And then I've got the same thing under here. And hopefully this will not be behind the video there. I know it seems to be stuck in the corner, and when I move it, it doesn't move for you. So let's hope that I can do this. Maybe I'll just write it down here. 5 times 2x is what? 10x cubed. 5 times negative 3x is going to be negative 15x squared. And 5x times 1 is going to be 5x. Well, this is easy with 1. 1 times everything is just going to be the exact same thing. So I'm just going to rewrite this here. Minus 3x, what was that? That was a positive 5x. And then plus 1. So when we add these together, I'm going to, running out of room here, it's 10x cubed, negative 15x squared, and positive 2x become negative 13x squared. And that is a positive 2x and a plus 1. So that's going to equal f times g of x is 10x cubed minus 13x squared plus 2x plus 1. And that is your final answer. All right. Last problem on this page. All right, excited about that, right? F of g of 2. Okay, so basically with this, you're going to do the exact same problem, and then you're going to plug in, instead of x, you're going to plug 2 into it. So since we've already done f of g of x, we don't have to do that work again. It's already done for us here. And then we're going to plug 2 into it. So 10, 2 cubed minus 13, and I'm looking right here, 2 squared, because this is where I did f times g of x, plus 2, and I don't feel like doing it again, plus 1. Plug that into my calculator. You probably on your calculator, it's easiest to get the cubed there. You're going to use your caret button. 10 open parentheses 2 close parentheses caret 3 minus 13 open parentheses 2 close parentheses squared plus 2 open 2 close plus 1 enter, and I got 33. So F times G of 2 is 33. All right. I hope that you were able to get all of those. I know it got a little, there were some tricks up my sleeve in those practice problems. But now going back to what we started to discuss in our key terms or lesson 1, even and odd functions. Now remember, even and odd functions have to do with how it's symmetrical. That means if you turn it or flip it a certain way, it's going to look exactly the same as it did when it started. So an even function is going to be symmetrical across the y-axis. Remember, the y-axis is the vertical axis. It goes up and down. So essentially whatever you have, if you could fold it closed and the graph lays exactly on top of each other, that's going to be considered an even function. Okay. Then an odd function means that it has symmetry about the origin, or origin symmetry. Okay. And so they're talking about in your lesson in the book, it talks about spinning it upside down. Well, I guess that's one way to look at it. If you took it and you spun it upside down, it would look exactly the same. But remember when we were talking about it in the last lesson, how it's defined is if it is flipped both over the x-axis and the y-axis and ends up in the same place, then you will have odd function symmetry. So let's flip it over the x-axis first, and it would show up as this yellow line. Okay, now we're going to flip it over the y-axis. This is the y-axis, so this would flip over here and it would go like this, and this one would flip over there and it would go like that, which the green, which was our last one, ended up exactly where we started, on the pink one that was already there. So if you flip it over the x-axis and then the y-axis, that is called symmetry about the origin, or odd function. It's an odd function because it has symmetry about the origin. It is symmetrical if you flip it over both axes. If it doesn't flip, if it doesn't fit either of those symmetries, we call it neither. So it's either odd or even or neither. All right. So if it's symmetrical across the x-axis, is it odd or even? No, it's neither. So if we had our standard parabolic function, oops, this is symmetrical across the x-axis. So this is neither odd nor even, because remember, even is across the y-axis, and this is not here. So this one is not going to be even. If it were on the point of origin, if its vertex was on the point of origin, it would be even, but it's not. This one isn't symmetrical across the x-axis. What am I thinking? Okay, something that is symmetrical across the x-axis, okay? Okay, how about this? That's a type of a variation of a absolute value graph. That one would be symmetrical across the x-axis, right? If you were to fold it from the top, fold it down, it would go directly on top of the other one. So this one is neither odd, nope, nor even, right? So this one is neither, okay? All right, so those were based on the graphs and what you could see. But what if you don't see the function? What if you just have it written out as an equation? Well, there's a way to check it. If all of the exponents in a function are even, then it's going to be an even even symmetry, right? So here we have a variable and it has the exponent of 2. So what is the variable of the exponent in this one? Well, if we had an x there, what variable would we need? We would need a variable of 0. I remember x of 0 is 1 and 3 times 1 is 3. So x to the power of 0 would not change this equation in any way. So all of our variables are even in this case. A 2 and a 0 are both even. 0 technically is not even or odd, but if something is ending in 0, it's going to be even. So that means that this function is even. Well, in order for it to be odd, all of the exponents of a function need to also be odd. That makes it really easy, doesn't it? If all the exponents of a function are even, guess what? The symmetry is even. If all the exponents of a function are odd, it has odd symmetry. That is so easy. Well, what happens if you have even and odd exponents? Well, I guess that would be neither, wouldn't it? So here you go. Let's just look at these odd ones because Miss Andrea, I see a 3 and that's definitely odd, but this one doesn't have an exponent. So how is that odd? Remember, there is an exponent there, but it's implied. It's implied 1, x to the power of 1. And 1 is, guess what? It's odd. So you have to remember those key features, those implied things about math. When you're doing math, you always have to remember those. So pause the video, tell me whether these are odd or even, and then come back and we'll go over it. This is 3, and this one is 1. So those are both odd. This is 3, this is 1, and this is x to the power of 0. So this is neither. This is 3, this is 2, this one is neither. This is 2, this is 0, so this one is even. I hope you got those easily. And last thing we're going to go over, I know this has been a long lesson, is the function even, odd, or neither. Well, this time we're going to look at the graph and see. Remember, even is over the y-axis. Odd is at the point of origin. So this one, if you folded it right here across the y-axis, it would fold directly in half and lay on top of each other. So this is even. This one, well, this one might be a little hard to see. If you spun it, I think that it would produce the exact same thing, but we can always double check it. If we were to flip this on the x-axis, this one would come down here and this one would come up here, and then we would have to flip it across the y-axis and it would land right on top of that, and this one would land right on top of that. So this is considered odd symmetry. All right, let's look at this one. Well, one thing you notice about having symmetry about the origin is it has to go through the origin. That's a hint right there. This one doesn't go through the origin, so it's not going to have symmetry about the origin, right? Absolutely not. And if we folded it in half, this one would be down here and this one would be up here. So it's not even. I don't think it's going to be odd because it doesn't go through the origin, but let's just double check. So if we were to flip this on the x-axis, this top piece right here would come down here. And then we would have this that goes up to here and up to here, right? Now we need to flip it across the y-axis. So if we took this and flipped it across the y-axis, it would go there. And if we flip this one across the y-axis, it would go there. Does that end up exactly on top of where we started? Well, no, it doesn't, because guess what? There's all this space right here in the middle. It did not end up exactly on top of this one for this amount of space. They kind of ended up in the same area, but here in the middle, it did not. So it is not symmetrical about the origin. If this graph, this one's neither. Let me erase this. If this graph had been moved up to where it crossed the y-axis at the point of origin, it would be symmetrical about the origin, aka odd. have odd symmetry. So, but that's a key feature you need to notice when you're looking for odd symmetry. If it doesn't even pass through the origin, you can automatically rule that off your list. So that's it for today's lesson. I know in the page online it had a little bit more, but we're going to take that and tag it on. It pairs nicely with page 3. So we're going to tag it on with page 3's lesson. And I will see you in a moment for lesson 3.